Okay, welcome back. This is just a brief introduction to server room design. Now, I know it sounds like an awful lot of engineering in here, but trust me, risk assessment takes place during the planning phase of building a server room. So let's just start. Where should I put the server room? Well, you might be thinking, well, I want my cables. So let's say I have a 5-story building. I want my cable runs to be relatively short, so maybe I'll put it in the middle of the building. That's one way of thinking. The other way of thinking is, well, let's just put it in the basement because there's very little foot traffic in there. Customers don't go down there at all, right? Or something like, or maybe it's at the top. But don't put it on the first floor where all the customers come in. That's probably a bad idea. So put it in the center of the building. If I'm looking at a floor plan top down, don't put it up against the wall where you have an exterior wall. Put it in the center of the room. Again, shorter cables, but it's also, no electronic, EMR kind of radiation, no, listening in on the conversation with the pane of glass being like a speaker, and no viewing, that kind of stuff. So another thing about server room location, if you're going to put it in a basement, make sure there's no pipes in the ceiling that could break or leak. And again, we're going to be talking about fire alarm systems and sprinkler systems, and this room probably needs to be completely separate. You may have a water system through all the rest of the building, but not in this location. So a lot of choices on where to build the server room to begin with. I'm building a brand new building. Where do I want to put it? Okay, you're probably going to need a separate heating, ventilation, and air conditioning system. It could be you won't even need a heater at all. It could be your server racks themselves will serve as heaters to keep that room nice and warm all by itself. But that's not practical because if there's an outage, you don't want it to be like freezing in there while the system is shut down. But the range is supposed to be between 60 and 90 degrees. Now, I have been in server rooms where you basically had to wear a jacket. It was cold. Yeah. And most of them are set like at 75 degrees. That's typically it. But you really need to calculate, what the heat load is of the server. And this is easy to do because you know that the wattage of the system, let's say, at home, I buy a computer and I buy an 800 watt power supply. Okay, so it's very easy to figure out that all that electricity is going to go to heat, right? All of it, 100%. So 800 watts. I know exactly how much heat is going to be punching out of this thing. Okay. So typically you calculate this with air changes per hour, ACH, and some sort of an exchange rate. You don't want to have the exact same air being blown over and over. You want some fresh air to come in, all that kind of good stuff. So there's an awful lot of calculation. So if you're going to an architect engineer firm and you're saying this is going to be a server room, their ears are going to peak up and go, oh, wait, that means separate air conditioning systems, separate ductwork, separate controls, separate air freshers, everything is different. The rest of the building is just, computers and humans, right? It's a typical office building. There's no manufacturing going on. It's just an office space, but that server room is going to be different. And then the humidity is kept right about 45, relative humidity at 45%. This basically prevents static issues. Okay. So redundancy. I really need to have more than one system. I can't have a single air conditioning system running my server room. It could be, well, the backup is the building's system. That'll probably work a little bit. I mean, it might survive an hour or two under that. Maybe you need to have one of those, in the wall split systems. Like if some hotels, when you go in, there's a thing on the wall, exterior wall, and so it's just a packaged unit that contains heat and air conditioning. It just blows, stuff from the outside. But it would require a lot of ductwork because I'm recommending you not put that on the outside. But some sort of redundancy involved, and clearly a separate zone. Because let me tell you, in the summer, everyone's be calling for air conditioning, but in the dead of the winter, everyone else is asking for heat. Every thermostat in the rest of the building is asking for heat to keep those poor humans from freezing to death. But not in the server room. It's asking for air conditioning. In the middle of December, it's asking for air conditioning. A separate filter. Now that sounds a little crazy, but just bear with me for a minute. Yeah, it's annoying to have allergens in the air. That, if you live in your home, and you might want to get a high efficiency, air filter that filters out more allergens. But in the server world, we're talking about, dust and contamination. Metal dust is really nasty. But anyway, I need to keep the dust down because I don't want to impede the amount of air. Now, in my house, when I crack open my computer and it's been sitting there for a year, and I crack it open and look at the fans that are in there, oh my God, they're caked with stuff, right? That's what we're talking about. And then there's a way you can build racks. So if you have a cold air in one side and it blows to the outside, all the racks could be facing the same way. So they all suck cold air from one direction and blow hot air out the back. Or you can stagger them, front to back, back to front, front to back, back to front, depending on how you want to do this thing. It's what's called a hot aisle and a cold aisle. Almost always, you want to have a system where, the cold comes in from the bottom and flows to the top, right? That's just kind of this common sense stuff. Okay, so let's talk about the difference between industrial air conditioning and the stuff you have at home. So at home, your air conditioning compressor turns off, right? When the temperature gets down to a certain point, you set your thermostat at whatever, 72. When it gets to 72, it turns off. In industrial scenarios, that the compressor never turns off. It runs 24/7. All it does is just change the amount of cooling that are happening. It's called pressure. Don't worry about what that means. But it doesn't turn things off. It just reduces the amount. So maybe you have at home, maybe you have a really sophisticated multi-stage compressor where the volume of air is constant. And the only thing that changes is the compressor is at 50%. Now it's at 40%. Now it's at 30%. But the volume of air is always the same. That's exactly what we're talking about here. And again, having a package unit as a backup, a traditional system, that might be helpful. We've had a scenario where we had a system go down and we got the gargantuan box fans and put them in the doorway and, it was blowing air in to make some air changes. It was a mess. Didn't actually work very well. We were watching the temperatures really, really closely. And when we got to the threshold where the machine started throttling down for heat, we went, it's time to shut them off. So it only lasted like an hour or so before we had to turn the machines off. So yeah, you need redundancy. Okay, so in the old days, this whole concept of a raised floor became very popular. I don't know who started it, but you're retrofitting an existing building. And so you built it with, you built a raised floor up. Maybe it was like, 10 inches off the ground. And the idea is that, all the wiring and maybe even the ventilation system was under the floor. And let me tell you, we had one of those. And oh my God, what a mess. I mean, all right. In my case, custodial did not go in the server room at all. And somebody, dropped a coffee cup or a slushie. And, since the floor tiles are removable, right, it just goes right on through, right in the seams of the thing. So one day it was time for us to, add some more cabling. So we got the little suction cup things and we started pulling floor tiles up so we could add more cabling. Oh my God, we had to go run and get hazmat suits. It was horrible underneath there. I mean, black mold everywhere. Just a total mess. It's one of those out of sight, out of mind things. Wow. Now, about the only time I ever see people talk about raised floors when we're talking about that hot-cold deck system where you push the air conditioning under the floor and it comes up immediately in front of or inside the server rack, and then the server rack blows the cold air out. I don't think anyone building a raised floor system other than for ductwork now. Okay, walls. So soundproofing, it's very noisy in there, right? A lot of servers running. Now, this could be for both you, and for the rest of the building, right? Okay. And fireproof. Now, let's talk about this. So a fireproof wall is typically going to be tougher, right? I mean, we're not talking about, sheetrock kind of stuff that you could just punch your fist through. I want a wall that's going to be hard to penetrate, or at least if you penetrate, you're going to make enough noise that the guards are going to notice, right? That kind of stuff. If somebody takes a sledgehammer and starts banging on this fireproof wall, trust me, they're going to get hurt, right? Okay. So, harder to break through. And there was an inspection that the Army did, and they went from installation to installation. They had a server room, and the walls didn't go all the way up to the roof system. It stopped, and they had a suspended ceiling, which means they had sophisticated lock, they had a cipher lock and all that. All I needed was a ladder, and I just lift up the ceiling tile, crawl over the wall, lift up the other ceiling tile, and drop down in. Like, wow, somebody didn't think this thing through. Anti-static floor, basically tile, don't have carpet, right? And then have big doors, not a standard, residential style front door, a 3-foot door. And so, or a 2/8 door for living room, bedrooms is a big, okay, like a 4x9, monstrously big thing. That way you can get machines in and out. If you ever had to wrestle a 19-inch rack through a door, you know exactly what I'm talking about. Or an up system with a battery pack. Oh, yeah. And then, of course, it has to be fireproof. Okay, so let's continue. So access, at least two-factor authentication with logging going on. I need to know who was let in. Now, video cameras, this is kind of sneaky. I don't want to have a video camera on the inside of the server room. That's a security issue in itself. But on the outside, you could have one that just records nonstop. Or if you had a rather quiet place, like it's in the basement, no one goes down there, maybe it'd just be motion activated. Something happens and it comes on, does its thing. That works. Keep a log, keep all this stuff, have visitor logs. And let me tell you, if I tell people, hey, we have a policy that you can't leave a maintenance person or custodial person unattended, well, I want to check. I want to make sure that you let them in and you stayed with them. I can tell by the videos. If you just walked up to the door and let the person in and walked away, I'll know that you violated policy, right? Okay. And then having logging for all this stuff, so I know to make sure everything is working. Okay, so racks. If you're building a server room, the 19-inch rack is the standard unit where you put servers. Basically, always plan for about double what your current need is. And in our case, people, if you have an empty spot in a room, people are going to want to dump stuff there. It's we're getting a furniture shipment. We don't have any place to put it. Like, no. But we would even tape off with tape on the floor where the next rack is going to go. So we could see there's 3 racks here, but there's 3 spots over here that are designed for future racks. Anyway, lots of room and lots of space around the rack. The rule of thumb is 3 feet. Make sure you have plenty of lighting, particularly in the back. One of the stories I love to talk about is, send the guy back and say, okay, we're getting ready to replace the email server. And so let's go back there and pull the plug. And, we already have the guy shut down. Just go ahead and pull the electrical plugs from the dual power supplies. And the guy goes back there with a flashlight and he unplugs the database server instead because he couldn't see what he was doing. And they weren't labeled in the back. The front had labeling, but the back of the rack didn't have any labeling. He didn't have, couldn't see what he was doing, and he unplugged the wrong thing. Seismic bracing or grounding, bolt these, one of those little guns, bam, pops through the concrete, that kind of stuff. And then this is something that I did, color coding for the DMZ rack. We had a separate rack just for the dirty side, the demilitarized zone. So all the rest of the racks were just normal racks, but we painted the outside rails red on the DMZ rack. And the idea is you wouldn't walk up and go, oh, wait, let me just hook a cable from this rack to that rack, temporarily. Once you saw this one was completely separate and different color, that meant no cable gets connected from this rack to that rack or this rack to this router. And it's all completely separated. So color coding the rack kind of makes sense. Hey, we're coming up on the 15-minute mark. You guys know how this works.